Hello students, question is calculate delta G naught for the following reaction Ag positive plus Cl negative forming AgCl solid given delta G naught for AgCl is given minus 109 kJ per mole. For Cl minus it is minus 129 kJ per mole, and for Ag positive it is plus 77 kJ per mole. Represent the above reaction in the form of a cell. Calculate E naught of the cell and find log base 10 Ksp of the AgCl. So in this question we have to find out the delta G naught of the reaction and the delta G naught of the product and reactants we are given. Also the cell representation and E naught and log 10 Ksp of the cell we have to find out. So first of all, the cell representation, it will be cell representation is Ag is converting to Ag positive, then AgCl electrolyte is used and Cl is converting to Cl2. So this is the cell representation. Now to calculate delta G naught of the reaction, delta G naught of reaction, it would be, first of all the reaction will be Ag positive plus Cl minus, it is forming AgCl solid, that is the precipitates of AgCl solid is forming. So delta G naught will be of the reaction, it would be delta G naught of the product, that is AgCl, minus delta G naught for the Ag positive ion plus delta G naught for the Cl minus ion. For AgCl it is given minus 109 kJ per mole minus for Ag positive it is given 77 kJ per mole, and for Cl minus it is minus 129 kJ per mole. So this gives us minus 109 minus 77 minus plus 129, and these values are all in kilojoule per mole. In kilojoule per mole. So this gives us minus 109 and minus 77 plus 129, this gives us minus 57 kilojoule per mole. So this is the delta G naught reaction when Ag positive and Cl minus ions, they are forming AgCl solid precipitates. This is the cell representation. So this is A, delta G naught of the reaction we have calculated. Now we have to calculate the E naught of the cell. Now E naught of the cell is related to delta G naught as delta G naught is equal to minus NF E naught of the cell. Delta G naught R we have calculated, that is minus 57 kJ per mole. N is number of electrons that are involved. So number of electrons involved are 1 electron will be involved because the oxidation reaction will be the Cl minus ions, they are forming, oxidation will be of silver. So oxidation reaction, it involves Ag solid, it is forming Ag positive and electron is released, and reduction is Cl2 gas, half Cl2, it is forming Cl minus ions plus electron is involved. So this is 1 electron is involved, it means N is 1. F is the Faraday's constant, that is 96500. So we will put the value of delta G here, that is minus 57 kJ per mole. So it will be minus 57 into 1000 joule per mole minus N is 1, 96500 into E naught of cell. So this minus is cancelled and E naught of cell will be 5700 divided by 96500. So this gives us the E naught of cell as 0.59 volt. E naught of cell is 0.59 volt. So this is the second part. Third is find log base 10 KSP of the AgCl. Now KSP can be calculated from K, that is the equilibrium constant. Now we will calculate K from delta G naught as delta G naught is minus 2.303 nRT log base 10 or log 10 K. Delta G naught is minus 57 into 1000. This is in joule per mole. That is equals to minus 2.303. N value is 1. R is 8.314 joule per mole per Kelvin into temperature. Now this reaction is given at temperature. So we will assume this at room temperature, that is 25 degrees Celsius. So it will be 298 Kelvin into log K. So this Kelvin is cancelled by per Kelvin, joule per mole by joule per mole. So we will have log 10 log K value, that will be equals to 5700 divided by 2.303 into 8.314 into 298. This is equal to 10. So log K is equal to 10, which is log base 10. So K value will be 10 raised to power 10, because log base 10 K is equal to 10 and K we have to find out, so its antilog will calculate it as this is raised to power this, that is become 10 raised to power 10. Now KSP will be inverse of this K. Solubility product constant will be when AgCl it dissociate to form Ag positive and Cl minus ions, and this K we have calculated when Ag positive and Cl minus ion they form AgCl. So KSP will be inverse of K, that will be 1 upon 10 raised to power 10, which is equal to 10 raised to power minus 10. But we have to find log base 10 KSP. So that value will be, this is equal to minus 10, because log of this will be, this minus 10 comes here into log 10 and log 10 value is 1. So it is minus 10. So I hope you understood the solution. Thank you.
Hello everyone, let's start the given question. The question says that there are two parts here. In part A it says that will pH value of water be the same at 25 degrees Celsius and 4 degrees Celsius? Justify not more than in 2 or 3 sentences. So we know that pH of water at 25 degrees Celsius is equal to what? It is equal to 7. This is at 25 degrees Celsius. Now we should know that when the temperature here is decreasing, that is from 25 degrees Celsius to 4 degrees Celsius, what will happen here? Now pH, that is your H plus condition, that is H plus ions, is proportional to the temperature. That is when the temperature changes, the concentration of H plus ions also changes. So when we are decreasing the temperature, that means the concentration of the H plus ion will. So now when the temperature decreases, that is from 25 degrees Celsius to 4 degrees Celsius, so when the temperature decreases, the self-ionization of water, that is H2O, will also decrease. That is the self-ionization of water decreases. Now when the self-ionization decreases, it means that the value of Kw will also decrease. Kw is what? Kw is the ionic product of the water. So that means when we are decreasing the temperature, the ionic product decreases, and when the ionic product decreases, which means that the concentration of H plus ion will also decrease. The concentration of H plus, as well as we can say that the OH negative ion will also decrease, because we know Kw is what? Kw is equal to the product of H plus ions as well as OH negative ions. So when H plus and OH negative concentration is decreasing because of the decrease in Kw, and we know that pH is equal to minus log of H plus. So pH is inversely related to the H plus ion concentration. Now when H plus concentration ion is decreasing, it means that the pH of the solution will increase. So it means when I'm decreasing the temperature from 25 degrees Celsius to 4 degrees Celsius, the pH of the solution will increase. That is, the pH of solution will be greater than 7 when the temperature will become 4 degrees Celsius. Now coming to the second part, in the second part of the question, this is your part A. In the second part, we have two students use same stock solution of zinc sulfate and a solution of copper sulfate. The EMF of one cell is 0.03 higher than the other. Concentration of copper sulfate in the cell with higher EMF is 0.5 molar. Find out the concentration of copper sulfate in other cell, and the rest data is given to us. So now firstly let's draw the cell here. We have been given zinc sulfate cell and copper sulfate. So we have zinc at anode and copper at cathode. So this is the cell here. Copper 2 plus copper. So this is our cell. So the E cell will be given by what? E cell is given by E naught of the cell minus 0.059 divided by the number of electron involved here will be 2 log concentration of copper 2 plus ion divided by concentration of Zn 2 plus ion. So this is our first case here. Now we can, in the first case, what we can do here is we can change this a little bit. We can make it Zn2 plus by copper 2 plus instead. Why I'm writing like this? I'm writing like this because I want that the E1 of the cell has a higher EMF than E2 of the cell. E1 is greater than E2. This is what I'm considering. That is why I've written Zn2 plus by copper 2 plus. So now this is my first condition and this is my E1. So I will consider this to be first equation. Now for the second case, what we can do here is we have 0.5 molar concentration is given to us. So instead of copper 2 plus, we will write here 0.5 consider. In the second case, we will keep the value as unknown. So E2 will become E naught minus 0.059 divided by 2 log concentration of Zn2 plus by copper 2 plus concentration. This is the second case. And now what we will do here, we will subtract second from first. So this will become what? That means E1 minus E2. So we will write E1 minus E2. So this will cancel, E0 and E0 will get cancelled here. We will get here 0.059, which we can approximate to 0.06 divided by 2. Then we have log value here 0.5, because Zn2 plus and Zn2 plus will get cancelled out here. So we will have here only copper 2 plus. So this is what we are going to get, E1 minus E2. So this value is given to us 0.03. This will also become 0.03 only log 0.5 divided by copper 2 plus concentration. This is your 0.5. Let me write this down again. This is 0.5. Now after this it will become this value will become 0.5. We can write down here divided by log 2 plus, and this value can become 10 here. 10.5 divided by copper 2 plus concentration. So here from this we can find out copper 2 plus, which will come out to be what? Copper 2 plus will concentration will come out to be 0.5 divided by 10. It means 0.05. So this is your answer to the question, which is part B. Thank you.